Hello. All right, so this is the video for solving with factoring, and I've got a couple of different examples. So one of the ways that you know factoring is an option is when you have multiple terms that have something in common. So we start off with tangent on both sides of the equal sign. That's the clue. So as my caution in the box over on the right, you never want to cancel. Oh, there's a tangent on both sides. I'll just cancel one. Tangent equals 1. That's not how it works. So don't do that. Technically, you're canceling them by multiplying or dividing it away. So just don't do that. So put it all together on one side equals 0. I like having the square or highest exponent term positive. So that's why I subtracted the tangent. And you can see writing it left or right, the tangent squared is always positive, and then minus tangent equals 0. It's all the same thing. If you moved the tangent squared to the left by subtracting it, you'd have tangent x positive minus the tangent squared term. Again, I just don't like that. You could do it that way, it's fine. Once you got everything on one side equal to 0, that's when you factor. You can only factor, see my little oval on the right side there? You can only factor when it is set equal to 0. You can't have it equal to 1 and factor or anything other than 0. That is straight out of algebra. That's got nothing to do with trig. Factor it. You can see that line right there. Each factor then becomes equal to 0. Again, this is just algebra. Where the last thing we do is the trig. Tangent x equals 0, tangent x equals 1. When you're solving, that's going to be the next to final step almost. Some trig function equals a number. And for the most part, these are going to be things you find on the unit circle. So pardon me, I got the hiccups. Quadrantal angles, or, the variations pi over 6, pi over 4, pi over 3 in the different quadrants like that. Okay, so let's think about these. We're going back to the Unit 1 material. What angle or angles, sometimes there's more than one, has a tangent value of 0? So my thinking, tangent is the quotient identity, sine over cosine, and for that to be 0, just the numerator has to be 0. So what angle has a sine value equal to 0? Well, again, visualize or maybe sketch the XY plane and think about which of the coordinates, X or Y on the unit circle, does sine get associated with? And it's alphabetical. I talked about that before. The X goes with cosine, the Y goes with sine. X before Y, C before S. So sine is going to use the y coordinate to get its answers. So the x-axis is where sine will be 0. So 0 and pi. That's how I remember it. You might, anyways. And then the other one, tangent x equals 1. The only way for that quotient, sine over cosine, to be equal to 1 is when the numerator and denominator are equal to each other. And the only place that occurs is the middle angle. Because that tangent is positive 1, that's going to be quadrant 1 or 3, and you can see my answers up there, pi over 4, 5 pi over 4. So the trig is right at the end, and it's just the unit circle stuff. I discourage the use of the inverse function. There are a couple of things on WebAssign, possibly the lab manual, where it's not unit circle, tangent x equals 7, for example, or tangent x equals 2.3. Then you've got to go to the calculator, and I'm going to do a video for that. I'm thinking I'm doing a video for this, so look for a video for that. Okay, another example of factoring. Again, we've got two terms. Terms are always separated with the plus. Sometimes terms have their own kind of subterms. So 2 cosine sine is one term in relation to the plus, but within it, the 2 and the cosine and the sine are different things there. Now, you might recognize that as a variation on one of the identities on the formula sheet. If you can factor, I would highly recommend you factor before trying an identity. Part of what you're learning, remember there's 3 learning objectives for solving. There's the basic algebra stuff we're looking at, there's the fundamental identities, and then there's the formula sheet identities. So you have to know, when do I use an identity, when do I not use an identity? So as we get all of this stuff done, you'll learn about it. But for now, the clue is multiple terms with the same factor. Both of these have a cosine. That would be the clue. Let me try factoring before I do something else. And you factored it, and then set each individual factor equal to 0 and solve that. So cosine 0, sine -1/2, and then you go through that same process. The only places sine or cosine are 0 or plus or minus 1 are the quadrantal angles. So just like on the first one, you just think about the axes, x or y, on that unit circle, that'll get that answer there. So in this case, cosine is 0 on the y-axis, pi over 2, 3 pi over 2. Sine x, that's the small number, so that'll get the small angle. Sometimes I write alpha equals over to the side. I think I did that somewhere. I don't remember where I did. I did it on the first video, just to remind myself. So the small angle, pi over 6, but it's negative. So we're going to look in quadrant 3 and 4 to get that answer. So 7 pi over 6, 11 pi over 6. Like that. And just one of the, how do I get these answers? So I think of, half a revolution is 1 pi. So if I'm going to quadrant 3, what's going to be a little bit past 1? So this first example, 5 would be a little bit past 1. This example, I'm going to quadrant 3, so 7. 6 over 6 pi is 1 pi, so 7 is a little bit past 1. And then for quadrant 4, I know the full revolution of the circle is 2 pi, which would be 12 over 6. So 11 is just a little bit short of that. So that's how my mind is. I don't always write that down or say, I did just say it, didn't I? All right, let's look at another type of factoring. This one is different because it doesn't have a tangent in all the terms. There's a +3 on the end there. But this is a type of factoring called factoring by grouping. And one of the characteristics is there are 4 terms. Now that doesn't automatically mean factor by grouping works. You have to see if it works. So the idea is that you take the 4 things and you pair them up, and you might have to think about it a little bit because it's not always the first 2 and the last 2, just depends on how they're ordered like that. But you look at each pair and find the greatest common factor, which in this case would be the tangent squared. When you factor that tangent squared out of that first pair, you see my parentheses, tangent +1 is left over. And then the second pair, both of them have a -3. So when you factor that -3 over, again, a tangent +1 is left over. Now, don't make the parentheses identical. That is kind of a double checking. If you made a mistake like I did on the first line, my parentheses are not identical. I didn't factor out the greatest common factor. I just factored out a common factor. So the goal of the factor by grouping is that if it works, the parentheses will be identical, and then you can move forward. If for some reason they're not identical, then it doesn't work or you made a mistake, and double check it. Again, you can only factor when it's set equal to 0. So that was the first thing that I did. Okay, once you've got the parentheses set up, the parenthesis is a term by itself. So separated by the minus in the middle there, we've got the parenthesis tangent +1 in both places, which gets factored out. You see my next line. And then what's left over, tangent squared -3. There. Now this is, I'm just describing it how I've always done it. You might, do your factoring differently, and that's fine as long as you get it right. That's fine by me. This is all just algebra. Okay, so set each individual factor equal to 0, and we get tangent x is -1, tangent squared is 3. So always do that plus or minus square root. If you just do the plus square root of 3, you've lost 2 answers. That's some points there. All right, so go through my thinking again, just like before. Tangent is the quotient identity, equal to 1. Sine is equal to cosine. This one is negative. We did a positive one earlier, scrolling up right here. But the negative tells us the quadrant, and the 1 tells us the reference angle. So negative for tangent, quadrant 2 and 4. Sine equal to cosine will be the middle angle. So quadrant 2, so a little bit past a half or a little bit short of 1, 3/4. And then quadrant 4, a little bit short of 2 pi, so 7/4. And then our plus or minus square root of 3, so plus or minus gets all 4 quadrants covered. And again, I'm thinking quotient identity. So which one of these pairs, the small number 1/2 on top or the small number 1/2 on bottom, is going to simplify to square root of 3? And by the time you get to the solving, you've done this back in the unit circle. You should have done it back in the unit circle. You've done it with the sum difference half angle formulas. So you should be a little bit familiar with it by this point. So the one on the right is the one that simplifies to square root of 3 by itself. So this is the large number. So this is sine. So this will get the large angle. It's sine because I'm just focusing on that numerator, because like I've said before, I remember everything about sine and then I use it to build upon to get my other answers. So the large number, large angle, all 4 quadrants, and you can see my rundown right there, pi over 4, pi over 3, 2 pi over 3, 4 pi over 5. All right, so all 6 of those are the correct answer. Last factoring example. This is a more traditional quadratic factoring, again, right out of algebra class. Some students will do this or any of these, a squared minus 2a minus 3, and then factor it just with the algebra. I just use the sign. So you can't see it because I'm not doing a real video of this, but when I factor this grouping, so quadratic term, same trig function, but not squared, and then a constant, that's that normal quadratic that you find in algebra class. I just lost my train of thought there. So I first write the parentheses just completely empty, because I know when I factor that, I got that double set of parentheses. I know the first part in the parentheses is going to come from the square term. So in this case, sine and sine. I know that the last thing in the parentheses comes from the 3 at the end, so 3 and 1. Then you think about where do the plus and minus go. So it's a minus 3, so I know they're going to be different. One of them's plus, one of them's minus. Then I look at the middle term and see it's -2, so I want -3 plus 1 to get that -2. Now, any of these factoring, once you have it in the factored form, you can distribute, multiply through, and go back to a previous step and double check your work. So if you have guessed wrong, if I had 2 negatives there, I'd multiply and get a +3. If I had +3 and -1, I would get a +2. So there's always a built-in double checking so that you know whether you did the factoring right before you move ahead and turn it in and don't get all the points. All right, set each factor equal to 0, solve that. The one on the left, sine x equals 3. We've touched on this a little bit with the unit circle and with graphing. So the unit circle, +1, -1. Those are the biggest and smallest values. When we talked about amplitude, sine and cosine always start with an amplitude of 1, and it's the number in front of the function. So if this were 3 sine x, that could equal 3. But it's not. It's sine equals 3, which can't happen, so no solution right there. Be careful with the no solutions. If you think that you've got something that offers a no solution, really justify it. Don't just no solution and move on. It could very well be you made a little mistake earlier, and you think about it. Go back and double check like that. But in this case, that is a no solution scenario. And then second one, sine x -1. Remember, plus or minus 1 or 0 for sine and cosine are the quadrantal angles. So where is sine going to be -1? The negative y-axis, which would be 3 pi over 2. That is the end of this video with factoring. There are probably other variations on factoring, but these are the most common ones. So be sure to do all that practice in the lab manual and WebAssign to get some experience.